For a few seconds, the dancers heard the building before they understood what was happening. The sound came from above them, not from the stage, not from the lobby floor, from the part of the hotel most people had treated as scenery. It was Friday evening, July 17, 1981. The Hyatt Regency in Kansas City was full for its weekly tea dance. Somewhere between 1,500 and 2,000 people had come to watch, dance, talk, and look up through the hotel's tall atrium. Above them, elevated walkways crossed the open space. People were standing on them. People were standing under them. And for everyone in the room, the building carried one silent promise. Someone had checked this. Then something overhead gave way. The fourth-floor walkway was directly above the second-floor walkway. When the upper walkway fell, the lower one had no chance to survive the impact. Both came down together into the crowded lobby. In the weeks that followed, investigators would trace the disaster back to something that looked almost harmless on paper. A small change, a simpler construction detail, a verbal approval over the phone. And after that change, the check that should have followed was not in the project record. This is the reconstruction of how a missing calculation became a warning, and how that warning stayed invisible until 114 people were dead. The Hyatt Regency Crown Center opened in 1980. It was new, expensive, and designed to impress. Its atrium was the centerpiece, a tall interior space filled with light, balconies, and suspended walkways crossing through the open air. The walkways were not hidden engineering. They were part of the hotel's drama. They made the lobby feel vertical. They turned structure into decoration. There were 3 suspended walkways. The second-floor and fourth-floor walkways were stacked directly above each other. The third-floor walkway was offset to the side. All 3 were suspended from the atrium roof by steel hanger rods running down through box beams. A hanger rod carries load and tension. A box beam is a hollow steel beam. And the place where the rod passes through the beam is not just a detail. It is where the load changes hands. From the lobby floor, none of that was visible. Guests saw music, glass, railings, and people leaning over the walkways. They did not see the rods. They did not see the washers. They did not see the welds. They did not see the connection that was holding the crowd above them. That night, the tea dance had drawn its usual crowd. Pamela Coffey was 11 years old. She had come with her father, Gerald. Thomas Henson was 46. He loved big band music. According to later memorial reporting, it was the thing that made him come alive. He came with his wife, Romelia. Ed Bailey was there too. So was Shelley McQueenie. Both survived beneath the fallen structure, badly injured. Bailey later described the assumption everyone had carried into the building that night. You do not walk into a new hotel expecting it to fall on you. That expectation is not naive. It is the contract between the public and the people who design the built world. And at the Hyatt, that contract had already been broken before the dancers arrived. To understand the failure, start with the original design. The first plan used continuous hanger rods. A rod would run from the atrium roof down through the fourth-floor walkway, then continue down to the second-floor walkway. In that arrangement, the rod carried the load in one continuous line. The fourth-floor box beam was part of the system, but it was not being asked to carry the second-floor walkway from above. The load path was simple: roof, rod, walkway, rod, walkway. Then construction created a practical problem. The continuous rods were long. Threading them and installing nuts over their ends was difficult. Fabricators proposed a simpler arrangement. Instead of one long rod, use 2 shorter rods. One rod would run from the roof down to the fourth-floor box beam. A second rod would hang from the fourth-floor box beam down to the second-floor walkway. On a drawing, this looks modest. One long line becomes 2 shorter lines. A connection appears in the middle. The geometry still looks clean. The walkway still looks suspended. But the structure was no longer doing the same job. In the original version, the second-floor load continued along the same rod. After the change, the fourth-floor box beam became the point where that lower walkway's load had to be picked up and transferred. That meant the upper connection was now responsible for much more than before. The rod, nut, washer, weld, and box beam were no longer just holding the fourth-floor walkway. They were part of the path carrying both stacked walkways. The drawing did not scream, It just quietly changed the load path. And that is the kind of danger engineering is supposed to catch. But the most disturbing part of Hyatt is not only that the connection changed, it is that the building gave people several chances to notice the danger, and each warning disappeared into process. Before the hotel ever opened, the building had already produced a structural failure. During construction, the atrium roof collapsed. This was a separate event before guests arrived, but it should have changed the temperature of the entire project. A building that has already suffered a structural failure is no longer a normal job. It is a building asking for a full stop. After the roof collapsed, the engineers reported that the suspended walkways had been checked and found satisfactory. But the later Missouri appellate record says the complete check of those bridges was not done. That matters because the walkways were not decorative. They were occupied structures hanging over a crowded public space. If the building had already warned the project team once, the next step should have been ruthless verification, not reassurance, not assumption, not informal confidence, verification. The third-floor walkway, the one offset from the vertical stack, did not collapse that night, but the appellate record later stated that it had a high probability of failure during the building's life. So this was not one unlucky connection. Two suspended spans collapsed. A third was judged dangerously vulnerable, and the building had already given the project team reason to look harder at the systems hanging over the atrium. Hyatt was not a mystery because nothing could be seen. It was a mystery because the right people did not stop long enough to connect what was already visible. According to ASC's later ethics account, the fabricators requested approval for the double rod arrangement by telephone. The structural engineer gave verbal approval. A written follow-up was expected. It did not come. That phone call matters, but not because a phone call is automatically wrong. Construction projects are full of clarifications, questions, revisions, and practical adjustments. A fabricator asking for an easier way to build something is not unusual. The danger begins when a construction convenience changes structural demand, and nobody records the calculation that proves the new version is safe. A safety factor is the margin between what a connection is expected to carry and what would make it fail. It exists because real life is not exact. Loads vary, materials vary, construction varies, people move, crowds gather. Failure in a public building is not recoverable. After the rod change, the question was simple. Could the new connection carry the new demand? Later, safety investigators would find no final calculation in the project record, showing that the changed connection had been verified. The record had no answer. That was the warning. Not a crack visible from the lobby. Not a beam bending in front of guests. Not a complaint shouted over the music. The warning was absence. And by 7:05 p.m. on July 17th, that unchecked connection was no longer an engineering abstraction. It was holding people above a crowded lobby. The weak point was not where a guest could inspect it. It was inside the meeting of rod, nut, washer, weld, and box beam, at the place where the changed load path asked the connection to do work the original arrangement had not required. The later NBS and NIST investigation identified the most probable initiation point as the box beam to hanger rod connection at the east end of the middle box beam of the fourth floor walkway. NASA's safety case study described the physical failure. The box beam split open along a weld, and the nut and washer on the support rod pulled through the beam. Once that connection could no longer transfer load, the load did not vanish. It moved. One connection released. The force shifted to neighboring connections. Those connections were already stressed. The additional demand was too much. The failure propagated. Then the fourth floor walkway fell. Directly beneath it was the second floor walkway. The lower walkway was carrying its own people, and then it received the impact of the upper structure falling onto it. It failed too. Both walkways came down into the lobby. The final count was 114 people dead and more than 200 injured. Pamela Coffey had come with her father. They died together. Thomas Henson and Romelia Henson were among the dead. Ed Bailey and Shelley McQueenie were pulled alive from beneath the lower walkway. Survivors spent months recovering. Families spent decades living with the fact that a night of music had ended under steel, concrete, dust, and glass. But the disaster did not end when the steel stopped falling. The next question was harder. Not what failed. Who had been responsible for knowing it would? Within days, the Kansas City Star began comparing construction drawings on file with the city against photographs of the wreckage. The difference was visible. The approved drawings showed the original continuous rod concept. The wreckage showed the changed double rod arrangement. The reporting identified the central issue early. The change had substantially increased the load on the upper connections. The Star and Kansas City Times coverage of the disaster would later win a Pulitzer Prize for local reporting. On July 21st, 4 days after the collapse, investigators from the National Bureau of Standards arrived in Kansas City. Their job was not to explain the grief. Their job was to explain the steel. There is a limit to what the record can recover. It does not preserve every word of the telephone approval. It does not show exactly what drawings or assumptions each person had in front of him at the moment the change was accepted. But it does show the outcome. The change was made. The verbal approval occurred. The written follow-up did not arrive. The calculation for the change connection was not available when investigators looked for it. That is enough to understand the failure of the system. Not every disaster gives investigators a perfect transcript. Hyatt did not. But it gave them something almost as important, a gap exactly where professional responsibility should have been visible. The most probable cause, according to the NBS and NIST investigation, was insufficient load capacity in the box beam to hanger rod connections. That is the engineering sentence. The accountability sentence was harder. The licensing case focused on the engineers of record, including project engineer Daniel Duncan and Jack Gillum, whose seal was used on the structural plans. The Missouri Appellate Record says the licensing board found gross negligence and misconduct connected to drawing review and the double hanger rod-to-box beam connection. Both engineers lost their licenses. Then came the word that made Hyatt impossible for the profession to treat as only a drafting mistake. Non-delegable. The responsibility for the structural integrity and safety of those walkway connections could not be passed down the chain. Not to the fabricator, not to custom, not to an informal phone approval, not to the idea that connection details were someone else's routine task. If the engineer's seal was on the structural plans, the engineer owned the safety of the design. ASC's ethics process reached the same basic conclusion. The seal meant responsibility. The engineer could not treat a life safety connection as someone else's detail. Engineering historian Sarah Fatiker later argued that Hyatt forced the profession to confront an uncomfortable gap. On paper, engineering ethics put public safety first. In practice, parts of the construction process had allowed critical connection responsibility to drift into informal custom, shared assumptions, and delegated detail work. Hyatt made that gap impossible to ignore, because when a connection fails in a classroom, it is a diagram. When it fails in a hotel atrium, it is a mass casualty event. Hyatt keeps returning in engineering classrooms because the mechanics are simple enough to teach. A continuous rod becomes two rods. The load path changes. The upper connection takes more demand. The box beam connection lacks capacity. The walkway collapses. A student can understand the diagram quickly. But the diagram is not the whole case. The harder question is how the diagram became a building. How did the change move through approval? How did the roof collapse fail to trigger a complete review? How did a public building open with a critical life safety connection that no one could later verify? That is why Hyatt is not just an engineering failure. It is a professional systems failure. The rod mattered. The washer mattered. The weld mattered. The box beam mattered. But the fatal object in the case was also the empty space where the verified calculation should have been. That space was not visible to the people at the tea dance. Pamela Coffey did not know about hanger rods. Thomas Henson did not come to inspect a load path. Ed Bailey did not walk into the Hyatt thinking about box beam connections. They were not participants in the decision to approve a change. They were not participants in the failure to document the check. They were simply there, trusting that the building above them had already been made safe by people whose job was to know. That is the point Hyatt forced the profession to absorb. A connection is not a detail once people are standing on it. The project file, the professional seal, the phone approval, the missing recalculation, those were not bureaucratic leftovers. They were the visible traces of a system deciding whether the public could trust the structure overhead. On July 17, 1981, that system failed. The warning was not hidden in the steel. The warning was in the file. It was the document that was not there.